Okay, we're going to look at an example of a show that question from Unit 1, May 2010, question 13. What we've got is a fish, an archerfish, which is going to spit a droplet of water out as an insect. And the question tells us that that droplet has an initial velocity of 3.5 meters per second at the top, and it's at an angle of 70 degrees to the horizontal. And the question says, show that the initial horizontal component of velocity for the droplet is about 1 meter per second. So the show that means we've got to do the calculation, and then we've got to show what our answer is, and to one significant figure it must be the same as 1 meter per second. And I've decided to call the initial horizontal component Vx, so I'm going to refer to Vx in my answer. So up the top here, this is what I did originally. I've drawn a vector diagram to find the component of the initial velocity. So this is the 3.5, this is the 70 degrees to the horizontal, this is Vx that we want to find the value of. And we know the cosine of 70 is adjacent over hypotenuse, so it's cos 70 equals Vx over 3.5. So to get Vx, we need to multiply both sides of this equation by 3.5. So down at the bottom here, this is where I've written out the answer. Vx is 3.5 cos 70 equals 1.20 meters per second. Important that you put the units in. And how many significant figures should you write here? Well, you should always write more than there are required in the answer. I generally do 3. And then you can show that by rounding up this answer to one significant figure, it's clearly the same as 1. And that means that the answer for Vx could have been anywhere between 0.5 and 1.49, and it would still have been equal to 1 meter per second to one significant figure. So that's my point there.